SN2 type of substitution reaction. In this topic, S stands for substitution, N stands for nucleophilic, and 2, the number which we have written here, suggests that it follows second order kinetics, or it is a bimolecular substitution reaction. So in this SN2 reaction, the rate of nucleophilic substitution reaction depends on the concentration of our substrate. Substrate is your alkyl halide, and also concentration of incoming nucleophile. So the rate of the reaction is depending or directly proportional to the concentration of the substrate, that is alkyl halide, and the nucleophile. And because it depends on these two parameters, it is called as bimolecular, and the reaction is of second order of kinetics. The rate determining step depends on both, that is substrate as well as nucleophile. So in this regard, we have an example where we have a primary halide which is represented as C, this in the plane, broken line suggests behind the plane, and wedge shape represent outside the plane, which is having Br. Now we have a nucleophile, that is OH minus, which approaches your substrate. This is your substrate, that is methyl bromide. The few things which you need to remember: the incoming nucleophile, which is OH minus, will attack your methyl bromide, that is your substrate, from the back side, because in the front side you have Br, and Br is also negatively charged or is having higher electronegativity value. That is why it will not attack from the front side, so it will prefer from the opposite side of the bromide, which is called as a backside attack. So SN2 reaction prefers backside attack. That is from this particular nucleophile. And the simple logic to it is because the Br and OH are all electron rich species and they repel. The next transition state or next intermediate step after this is the carbon will have both Br and OH represented in this way, where carbon and Br bond is now breaking, which is represented by a broken line, and carbon and OH bond is also in a forming form, that is new bond is formed between carbon and hydrogen, but is not fully formed. So the transition state contain both OH as well as Br, which are partially bonded to the carbon, which is represented here. The C bonded to Br is not completely broken or cleaved, and whereas C dash to OH is also not completely formed. The hydroxide ion will have partially negative charge because it has started to share its electron with the carbon. It was previously fully negative charge. The bromide also carries a partially negative charge because it has started to remove or take its electron share from the carbon atom. So it is trying to take the electron share, that is why it is partially negative charge. In that case, carbon will have hydrogens represented in this way in the transition state. The energy needed for the breaking or cleavage of C and Br bond is provided or partially provided by the energy liberated or released when C-OH bond is formed. What happened next is Br is completely removed as a leaving group, and OH completely forms a bond with carbon. And what happens is the hydrogen which were represented or were having configuration here will reverse its configuration, where hydrogen which was here will be written in an opposite way. Broken will be this way, wedge shape will be this way, as it is inverted umbrella shaped. So what is represented is, in the course of the reaction, the configuration of the carbon is inverted like an umbrella blown inside out. It is actually opposite of all this representation. It is actually inversion of the configuration. And as this inversion of configuration was given by a scientist named Walden, this type of inversion is called as Walden inversion. Usually in exams they may ask you explain the concept of Walden inversion in alkyl halides. So you need to explain everything about alkyl halide first and about SN2 reaction, and then represent the reaction what we have written here. And this is not step reaction, this is single step reaction. You don't have one step, second step or third step. This is one step reaction which is having an transition state. And SN2 reaction does not require ionizing solvent. Ionizing solvent is not required in SN2 reaction, whereas in SN1 reaction we require ionizing solvents. So this is very simple yet very important for your coming semester exams, which they will ask you explain bimolecular substitution reaction in alkyl halide. That means you need to write about SN2 reaction. They may ask you represent the Walden inversion seen in alkyl halides. And one thing has to be remembered, methyl bromide is primary in nature because this is only methyl bromide. This is not tertiary or primary or secondary. This is CH3Br. This is only alkyl group or alkyl halide. We need to